Hello, my students. Again, we are in section C of Unit 2, October 2023. This section talks about question 21. In this question, about some organic molecules which are important in the production of adhesives and coating materials. Compound X is a liquid containing carbon, hydrogen, and oxygen only. A sample of X with a mass of 1.92 grams contains 1.808 grams carbon and 0.23 grams of hydrogen. Use this data to find the empirical formula of X. It's very, very easy. You know, the empirical formula can be found by converting the mass into moles. So we have 1.92 mole mass of what? It contains 1.08 carbon. So carbon is 1.08 grams. You divide over 12 to find the moles. And then we have 1.131 grams over for hydrogen, which is what? Which is 1 over 1. And the continuity is what is known 0.0709. It comes from the 192 minus the 1.08 plus 0.1314 for carbon and hydrogen, and this will be over 16, and the answers are, this will give us 0.09, and this will be 131.131, and this is, it will be 0.0436 or something like that. Now, if you divide over the smallest, which is this one, if you simplified it by dividing over the smallest, the ratio will be 2.032 the smallest is not this one, it's 0.04, so it is 2.96, and this is to 1, so you can find it is round, you can round this 2, and this a 3, and this 1, so it will be C2H3O. That's the empirical formula. Now, the mass spectrum of X is shown, and deduce the molecular formula of X using the mass spectrum and your answer to AI. In the mass spectrum, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will equals to 1, 2, 3, 4, 5, 6. So this gives us 86 molar mass of the molecule, and from the empirical formula we can calculate 2 times 12 plus 3 plus 16, so 24, 27, 37, 24, 30, 40, 43. So 43, so the ratio is 2 to 1. So you shall multiply it by the molecular formula is C4H6O2. Since you multiplied it again, it's C4H6O2. Since you multiplied it by 4 by finding the ratio between the molar mass of the empirical formula and the molar mass of the molecular formula that we found from the x-axis in the mass spectrum of the question. Okay, let's go further in the question. Reagents were added to separate sample of X to identify the functional groups in the molecule. Complete the table 1, bromine water decolorized. So the functional group, my lovely students, is C, double bond C, and the aqueous potassium or sodium carbonate, there is an effervescence. This means that we have an acid or carboxyl. Using your answer, using your answer to A3 and the mass spectrum to complete it, so the formula of the 41, okay, you will see that it's 41. It is double bond. It is double bond, yes. It will be C3, H5 positive, or you can draw it for the examiner. C, and it is double bond. So C3H5. So here we have 3, and here there are 3 and 2. Sorry, because this is attached. So that's the idea. Now, 45. For 45, it will be this one, COOH. That's positive. If you add them to each other, or you can draw COOH since it's the functional group. X does not show the geometric isomers. It draws the possible displayed formula of X. So it's very easy. Here we have a carbon-carbon double bond. And you are talking about C double bond OOF. And here we have hydrogen. 1, 2, 3, because they are C4. Wait. So it is not, it will not show the displayed formula, or it will not show, yes, it will not show, yeah, we can write CH3 like that, 1, 2, 3, 4, and here we have hydrogen. That's the displayed formula, or you can show all bonds in the hydrogen. Right? Okay. Here we have propanoic acid can be produced industrially from propan 1,2,3 triol or glycerol, byproducts of the manufacture of biodiesel. This is the propanoic acid produced industrially from propane 1,2,3 triol, a byproduct of the manufacture of biodiesel. The first step is the dehydration reaction to convert the gaseous propane 1,2,3 triol to propanol. This reaction requires a solid catalyst. Okay. Explain how the catalyst increases the rate of this reaction. Use the Maxwell-Boltzmann distribution. Shown refers to the collagen's theory. And here you shall use the highlighting. I will use this one. We are looking at this area in the graph. Okay? Why? This represents the number of molecules which they have activation energy or mole, if or more. If you use the catalyst will provide an alternative route for the reaction, and it will elevate this area. So this means that the catalyst provides an alternative route for the reaction with energy, okay, that's smaller than the activation energy, a new activation energy which is smaller than the activation, and this will increase the number of particles which they have this amount of energy and they can collide successfully. The propanol is then oxidized to propanoic acid. Write an equation for the reaction using the O between brackets to represent the oxygen from oxidizing agent. It's very easy. You can write the equation like that. Okay. So here we have CH2. I opened the paper from my phone because just not to return back. So that's the X, or the product, which is the aldehyde plus the oxidation of it. It will give us the double bond as it is. Okay, and we have the COO. That's the oxidation, since the number of oxygens was increased in the structure. Okay, one synthetic route for the production of propanoic acid using propene derived from crude oil as a starting material. Propene goes to propane 1-diol, propene 2-ene-1-ol, propanoic acid. Suggests a suitable reagent and conditions for the conversion of propene to propane 1-diol. This is acidified potassium dimanganate or permanganate, or acidified and cold. Then acidified, cold potassium manganate 7. So just why the production of propanoic acid from propane 1,2-triol is more sustainable than its production from propene. It is 1,2,3 propanoic acid. Okay, since that's very important for propene, it is related with the environment. It is related with the environmental issue. Yani for the propene 1,2-triol, that's what's known as glycerol. So it is renewable resource, and only the product in this is water, and also the manganese compounds to be, and from propene the manganese compound shall be separated. So let me repeat that. Here we have the 3. That's a renewable source. Water is only the product, and in the other one, the manganese substance shall be separated from the reaction mixture. Like that, you will get, inshallah, full mark for this paper, and follow me for more details about different units for A level or international advanced level for Edexcel board and Cambridge board also. More videos, you will find them on our platform. That's me, Bishr Samhan, chemistry teacher on MetaStars.